Hello friends, welcome back to the CSC Guide. This is our third lecture of we discussing second chapter in computer networks. So let us start with error detection and correction mechanisms with examples of sense protocols. Error detection and correction mechanisms are essential in data communication to ensure the integrity of data transmitted over a network. There are several mechanisms used to detect and correct errors, including parity check. A parity bit is added to the data to make the total number of ones either even parity or odd parity. The receiver checks the parity and requests retransmission if it doesn't match. Checksum. A checksum is a numerical value calculated based on the data and appended to it. The receiver calculates the checksum and compares it with the received value. If they don't match, an error is detected. Cyclic redundancy check. A cyclic redundancy check is a more advanced error detection mechanism that uses a polynomial to calculate a checksum. It is more reliable than a simple checksum. Error correcting codes. This codes cannot only detect errors but also correct them. Examples include Hamming codes and Reed-Solomon codes. Now let us see some sense protocol that use these mechanisms. Transmission Control Protocol. It uses checksum and CRC for error detection and correction. Next is User Datagram Protocol. It uses checksum for error detection but not correction. Next is Ethernet. It uses CRC for error detection and correction. Next, let us discuss different versions of carrier sense protocols. Carrier sense protocols are a type of medium access control protocol (MAC) protocol used in local area networks (LANs) to manage access to the shared medium. There are two main versions: carrier sense multiple access (CSMA). In CSMA, a station senses the carrier, that is, checks if the medium is busy before transmitting. If the medium is busy, the station waits until it becomes idle. There are three variations of CSMA. First, one persistent CSMA. A station transmits immediately if the medium is idle. Non-persistent CSMA. A station waits for a random time before resensing the medium if it is busy. P-persistent CSMA. A station transmits with a probability P if the medium is idle. Next protocol is carrier sense multiple access with collision avoidance. In CSMA or CA, a station senses the carrier and waits for a random time before transmitting. This reduces the likelihood of collisions. CSMA or CA is used in wireless LANs and is the basis for the IEEE 802.11 standard. Next, let us explain about the changes in Ethernet standards. The Ethernet standard has undergone several changes since its introduction in the 1980s. Some key changes include Ethernet 10 Mbps. The original Ethernet standard introduced in 1980 operated at 10 Mbps. Next is Fast Ethernet, which is 100 Mbps. Fast Ethernet increased the speed to 100 Mbps. Next is Gigabit Ethernet 1000 Mbps. It was introduced in 1999. Gigabit Ethernet further increased the speed to 1000 Mbps. Next is 10 Gigabit Ethernet or 10,000 Mbps. Introduced in 2002, 10 Gigabit Ethernet increased the speed to 10,000 Mbps. Next is 40 gigabit Ethernet 40,000 Mbps and 100 gigabit Ethernet 100,000 Mbps, introduced in 2010 and 2014 respectively. These standards further increased the speed. Next, let us see some differences between bus backbone and star backbone. A bus backbone and a star backbone are two types of network topologies used to connect multiple segments in a LAN. Bus backbone. In a bus backbone, a single cable, the backbone, connects all devices in the network. This cable is shared by all devices, and if it fails, the entire network goes down. Star backbone. In a star backbone, a central device, a hub or switch connects multiple segments. Each segment is connected to the central device, and if one segment fails, the other remains operational. Next, let us see some differences between repeater and amplifier. A repeater and an amplifier are both used to extend the length of a LAN, but they work differently. Repeater. A repeater amplifies the signal and regenerates it, allowing it to travel farther without degrading. It also cleans up the signal, removing noise and distortion. Amplifier. An amplifier only amplifies the signal without regenerating or cleaning it up. It is a simpler and less expensive device than a repeater, but it can introduce noise and distortion into the signal. Next, let us see some important points. What is a transparent bridge? A transparent bridge is a network bridge that forwards frames based on MAC addresses without modifying the frames or alerting the sending stations. Next, how does a repeater extend the length of a LAN? A repeater extends the length of a LAN by amplifying the signal, allowing it to travel farther without degrading. Third, what is the difference between a forwarding port and a blocking port? A forwarding port sends frames out to the connected segment, while a blocking port does not forward frames, preventing loops in the network. Next, what is the difference between a bus backbone and a star backbone? A bus backbone is a single cable that connects all devices, while a star backbone uses a central device, hub or switch to connect multiple segments. Now next, let us define MAC, medium access control. It is a sub-layer of the data link layer that manages access to the network and resolves collisions. Next, what is the access method used by wireless LAN? The access method used by wireless LAN is CSMA or CA, carrier sense multiple access with collision avoidance. Next, what are the functions of MAC? The functions of MAC include framing, error detection, flow control, and access control. Next, let us mention the types of errors. The different types of errors are single bit error, burst error, and framing error. Thank you.